And we're off. On stage with us is Nikola. Everybody, can we have a hands down for Nikola? He came all the way from Facebook, from Planet Facebook, to give us a talk here.
Hi, everybody. Good evening at this point. Thanks for coming, for not going to the bar just yet to drink beer. My name is Nikola. I work as a production engineer at Facebook Dublin. I'm originally from Serbia, although not from Belgrade, from a small town not too far north from here. And we will not be doing live questions. I think, same like Mikey earlier this morning, I would like people to come and talk to me, so Boyan, do the shut it down. If you come and talk to me, we have stickers, so I mean, even if you don't come and talk to me, you can take the stickers, but I think it's better if people come and talk to me outside at the bar or in the hallway. So as you can tell by the font, I will be talking about the ancient art of service monitoring, but updated to the 2018 or now almost 2019 standards. I work as a production engineer at Facebook, a little bit about myself. I will not be talking about what production engineering is in this talk specifically, but again, grab me in the hallway and I will talk to you about what we do as production engineers and how this is different than software engineering as such. I was a software engineer for a number of years before this, and I worked in a bunch of places doing all sorts of things. I worked in small web startups. I worked in on low-level stuff. I worked for big telco companies, and none of the things I worked on was really monitored correctly. So I find this topic very exciting because I think it can be much better than it normally is. Since this is a Python conference, the talk will not be specifically about Python, but a lot of the stuff I will talk about we use extensively in our Python services. We like Python at Facebook a lot, especially in production engineering. We have currently tens of millions of lines of Python code in production as we speak right now, making sure all of your photos get wherever they need to go. Most of the code we run in production is Python 3, majority of it, last I checked. And yeah, we have also open sourced a number of internal tools and libraries we used. If you go to our GitHub page or our open source page as a company, we really are definitely very much into Python. So it's a good thing since we're kind of hiring as well, and you guys are also into Python. So yeah, putting it out there. Cool. So what this talk is about, since it's not about production engineering, not about Python as such, it's about modern industry practices for monitoring production code. It's supposed to be a cohesive yet ad hoc set of ideas. Some of these might be familiar to you. Some of these will be hopefully new to you. And you will walk out with new ideas about how you can make sure you know what's happening in your production code better. I think monitoring needs to be first class in 2018. It should be as ubiquitous in your process as Git is, for example. Most of the time, or some of the time, it is not. So I want to spread the word off using data to figure shit out. Okay, cool. So what to talk is not going to be about, apart of these two things, it's not going to be about the history of monitoring. It's a long topic, so not about that. It's a long topic that can be a talk on its own. I will not go into this, but it's very interesting to see how we got to where we are and why. And it's not going to be about specific tools. I will mention some tools that we use in Facebook and some open source tools, but I will not go into the specifics of tools. It's going to be about higher level ideas. Cool, so a word on words. What do I really mean when I say monitoring? If you've been anywhere around tech Twitter lately, you've probably heard about observability. And the reason I don't use this word is because I think it's a marketing term that's used by vendors to differentiate themselves, which I think is cool, but I don't think it needs to be set aside because it's just one data point in a long history of like, what the hell is happening with this crazy code that I run in production. So what I mean by monitoring is like having logs and metrics that you turn into charts and alarms, and that you can do, and this is very important, real-time querying and aggregation on, and potentially some offline analysis. So this is what we will be talking about. Cool, so since it's late in the day, I've split this talk into 4 parts and given it quirky titles to keep you folks engaged and from going to the bar. So first part is going to have the title, the question, the knowledge, the trial, and the final part, the legend. Okay, yeah, cool. So, chapter 1, the question, or rather asking the right questions. And I borrowed this extensively from the Google SRE book, the first one. And basically, like, what you need to know from your data comes down to 2 things. It's a what and a why. Very simple. What is happening to my service? But when you're asking this question, you should really be asking, what is my user seeing that is happening to my service? And it's a good mindset to have in software in general, even if you're not dealing with users directly. Think about who your users are. Make sure you have them in mind because they're what matters. SLA might be a bad word for some. I don't think it is because it makes you think about what are you promising to your users. Okay, so once you know what is happening, you need to figure out why bad things are happening. And that is where all the rest of the data will come in to help you figure it out. So this brings us to knowing your audience. I think this is very important in life in general. This is why I added the Python slide in this version of my talk, because this is Python audience. But it comes down to different people will want to know different things from the data. And even sometimes same people doing different things will want to know different things. So for example, person developing a feature will want to know different things than that same person being on call, woken up by a pager in the middle of the night. Marketing people will want to know different things that developers may not care about, but you may want to collect. Cool, so, but you also, to be effective at answering the questions, you need to know the code. And this is really important. You need to understand what's happening throughout your system. This is how you build reliable systems, by knowing shit, not by guessing. Know how your frameworks work. Like lots of people run Django here, it's a big thing here. Know how your Django app interacts with your web server. How does this whole thing run together? How many threads do you have? What are the resources that they're going to be contending on? This is what you need to know. Things are going to fail, and you need to know how things fail. What happens when things start taking way longer than they normally do? What happens when latency spikes 10x? What happens when DB is away? All of these things are things you probably want to start measuring and asking questions about. Debugging. The reason I use firefighters in this slide is not because debugging at Facebook is like this all of the time. It comes from a book called Thinking Fast and Slow, where the authors talk about, psychologists by the way, talk about how human brain has a fast and a slow path. And experts train their fast path of the brain to react to cues in the environment much quicker than if they were using their higher cognitive abilities. So they give an example of firefighters who are trained to notice things in a room on fire. Again, not to be confused with like running services at Facebook, and make quick and sound decisions based on evidence that they process quickly. So this is where you want to get to with your monitoring data, right? You want to be able to make quick decisions without spending hours thinking about it. Okay, moving on. Chapter 2, the knowledge. This is, by the way, the picture of the long room of the Trinity College Library in Dublin, where our office is based. Pretty cool place to visit, and drop by the office. We're hiring, by the way. Cool, so collecting all of this data. Well, there's several places you want to collect it from. Host level, this is your, CPU, memory, network connections, all that kind of stuff. This may not be very useful for figuring out when things go wrong, but can be super useful for figuring out why they went wrong. Service level, so this is like basically what your actual app is doing. Mesh level. Now I split this as a separate thing because I think it's very important in large distributed systems nowadays. Basically, when I say mesh, I mean your networking layer. Usually, most people running like distributed systems abstracted their networking, which entails, like service discovery or, back off failovers, all of that kind of stuff into a specific library or a subsystem. And getting data from this is like basically the beating pulse of your distributed system. That's why it's so important. We use this extensively at Facebook to figure out what's wrong, and this is like most of the time the first place where we look. So that's why it gets a special blue spot on the slide. And then like higher aggregation level, depending on how you deploy your services. If you run on public clouds, you may not care about this, but if you like run on actual hardware, like you might want to know that something is contained to a specific thing that lost power or network or something. Cool, so on this highly scientific diagram, we have a mesh here. I will explain how this actually happens. And basically, the takeaway from this slide is that we have an agent that collects this and sends this off. Now, this is a really good practice because you do not want to couple your metrics to your service development. You want to have like a metric system or collection system separate because usually it has separate reliability, separate performance concerns, separate people working on it, caring about this. So it's usually, at Facebook at least, we run it as a completely separate service that runs on every host in our fleet or most hosts and collects data. We can deploy services independently knowing that data is going to get to where it needs to go. And this is what I will talk about when I say always on data and why it's good. We will see. Stay here. And then we run a lot of Linux servers. We send it off to collection pipelines, which are again a topic on their own that can cover a number of talks, even books, and I will not go into it this time. Cool. So when I say metrics in real life, going into concretes, I mean counters and logs. Counters are for counting things. They can be aggregated, and aggregation can be really, really useful because they can be done client-side, and then a lot of the processing is offloaded to your leaf nodes. Aggregations are really important, and how you aggregate data, percentiles versus averages. Sometimes averages are highly misleading. Sometimes they're good enough. Depends. Then we aggregate all of this stuff, send it off to a time series DB. Time series DB is basically like a database that holds your data indexed by a namespace, key, and a timestamp. So you have a time series, hence time series DB. Facebook is part of the ODS system, which is the big system we use for all of this kind of stuff that also does all of the aggregation and alarming as well. We've open sourced the actual engine that does storing of the ODS. It's open source. You can look at it on GitHub, and there's an article about this. It has an interesting design characteristics that it heavily compresses stuff, data that is, so that you can query it from memory. And this is very useful because you can do real-time queries, which are really, really important, as I will attempt to show subsequently logs. But when I mean logs, I mean structured logs. Gone are the days of printing things to a terminal and considering these logs. Well, they're maybe not gone, but like if you're running a large system, you probably want to have some kind of dimensions. So this is like not a completely made up example in Python, coincidentally, of like what kind of metrics you want to send as part of your logs. So you have like a task, a service, what call was made, arguments, all that kind of stuff. Now, when this gets interesting is like, what if I told you, I can't put memes in slides because of legal, but what if I told you that you could aggregate across any of the dimensions that you log on? So this is a real example, again, from one of our systems called Scuba that lets you do exactly that thing. And this aggregates by whether the request originated from a different data center. Now, this is kind of like not a very interesting example because everybody knows that requests take longer if they come from a different continent than if they come from like 5 meters away. But like, this is there to simply illustrate how you can like dive into the dimension. Therefore, the system is called Scuba. It is not open source, but there's a paper on it, and it's interesting to read just to see where the design ideas came from. And when I talk about always-on data, I talk about service frameworks, because if you have a company or a team and you run a common framework, then metrics can be part of that framework, and everybody can use them for free, and it's always there. We'll see why that's cool. Cool, so Chapter 3, the trial. What happens when things go wrong? Or alarms. Brief dive into alarms. And if there's one rule of alarms that I can give you right here, it's favor signal over everything else. If there's an alarm, it should really require a human to look at it. If it doesn't, turn it off because it's annoying. Alert and symptoms, and this goes back to thinking of your users. You want to alert on requests failing. You do not want to alert on high CPU because literally no one cares about high CPU except maybe you, and it doesn't mean anything to your users. 500s do. Another kind of like corollary is if user reports an issue, your alerts have failed you and you need to go and look and why did you not see this coming and why did your users tell you about this. And if you have data always on, you can figure it out. So now, the last part, the legend, stories from the battlefield, where I give you a few examples of how we actually use metrics to figure when things went wrong in some of our systems. So the first thing I'm going to talk about is a memory leak we found recently. I think Dan Claudio, my colleague, will be talking a little bit more on Sunday about this specific example. But a pretty simple chart. It's memory usage for like 2 workers. One of them is the stable version running in production. The other one is what we call a canary version, which is like a new version deployed to a subset of hosts. And you can see that there's clearly a memory leak there, like it's off the charts. Well, not literally, but because it's almost off the charts. And then we like deployed the fix, it didn't work, deployed another fix, it kind of worked, we wanted to make sure, and then it works. But what this tells you is that you can actually use metrics to do a thing called metrics-driven development. It's hotter than test-driven development. You can even integrate it with your release process and make sure you don't ship any kind of regressions you care about. Again, care about the things your users care about. Okay, scary slide, the deadlock. Everybody knows what a deadlock is. Who can guess what's plotted on this chart? Close. It's available threads per worker. So what happens is like we had the deadlock, certain requests would lock up a thread. We would run out of threads, and then we would stop responding to a heartbeat. Deployment system would think, okay, the service is dead, so I need to restart it. Starts back up, has a lot of threads, starts receiving requests, deadlocking, same thing again. So if you have data like that, you can use it to validate hypotheses. Start from a hypothesis, dig deeper, rule things out, figure out what's wrong. There were, of course, other metrics we could have looked at to make sure that things were deadlocking, but this is an interesting one because it's not straightforward, and I think this is the first one we looked at. If you have always-on data, this is like you just dig in. Okay, this is another one where the phantom glitch. Anybody knows a situation when somebody pings you, says like, oh, something was wrong like 5 minutes ago, but now it's back up. And you're like a busy person, and you're like, you know what, it's back up, I don't care, I have better things to do. Well, if you have data always on, you can actually go like, yeah, let me take a look. And you take a look, and we actually did notice that something was wrong, and it was about an assumption we made about how we deployed our service and what the latencies were. Some things made latency spike like 10x. Things started timing out. People noticed. And because we had data, we could go back and fix these kind of things, which means gremlins go away, like things changing around in the infrastructure don't get lost. They're in the pile of data, and if you can slice it and dice it in real time, you can find gremlins and kick them off the plane. Cool, so this is the last slide. We're almost done. I will leave you with like 5 takeaways. If you don't take anything away from this talk, take only these 5 things. So monitoring should be like Git. You should monitor your code. It's really good. Data makes debugging fast, and real-time data makes debugging faster. Don't wake people up for noise. And monitoring is not only for production. And as I mentioned, we're hiring. Thank you. There's stickers here. Grab me after if you want to chat. Hi, I'm Nikola. It's great to be here at PyCon Balkan. I've been part of the community for over 10 years, and this is the first time a conference like this is in my home country, Serbia, so lovely time. Thanks.